is a peristaltic pump. A peristaltic pump is a type of positive displacement pump used to move a variety of fluids. Instead of using internal impellers or valves that come into direct contact with the liquid, it confines the liquid entirely within a flexible tube fitted inside a circular pump casing. The word peristaltic comes from peristalsis, the same natural wave-like muscle contractions your body uses to move food through the digestive system. In engineering, we replicate this by using a rotating mechanism to mechanically squeeze the tube and push the fluid forward. The way that this pump works is the central rotor spins and the roller pressed against the flexible tube. This pinches the tube completely shut and traps the water inside. When the rotor keeps turning, the roller moves along the length of the tube. It forces the trapped water forward just like squeezing a tube of toothpaste. The roller passes by and releases the pressure. The tube springs back into its original shape. This action creates a vacuum. The vacuum pulls fresh water into the inlet. The peristaltic pump is commonly used in medical and pharmaceutical applications, water and wastewater treatment, and food and beverage industry.
The process of turning is to mark the 21st length of the workpiece from the original length. The process of turning is where the part is rotated while being machined. The cutting tool is set at a certain depth of cut. When the rotating workpiece hits the tool, it removes the surface of the workpiece. The process of turning is not only to mark the length of the workpiece, but it is also to give a good finishing for the surface of the workpiece. The next process after the turning process is drilling on the workpiece. The reason drilling is after turning is to mark a location and to create a small diameter hole for the boring operation after the drilling operation. The drilling operation is very important. This is to make a hole big enough so that the tool for boring operation can fit into the workpiece. For the drilling process, a small starting hole is made with a second drill before the start of drilling with a bigger drill diameter. lebih. 25 lah dulu. After the drilling process, to create a small hole for the boring, the process of boring is executed. The cutting tool for boring is mounted on the boring bar to reach the full length of the bore. The process of boring is executed to make the hole in the workpiece bigger by the increment of 1 mm. The process of boring is also to make a good finishing for the surface inside of the workpiece. Then, the process of milling is executed. In this project, however, milling is used on part 1 to remove additional length of the workpiece. The milling process is executed by removing the top surface of the workpiece by the increment of 1 mm. After the milling process, we can finally get the accurate and precise dimension of the workpiece. Although this time, the drilling process is executed inside of the workpiece. The reason to drill inside of the workpiece is to get 2 holes dimensionally accurate for the workpiece. During the drilling process, it is advised to pour some oil on top of the drilling area. The oil is used during drilling to act as a lubricant and coolant. It reduces friction between the drill bit and the material, prevent the bit from overheating, and help flush away metal shaving. This significantly extends the lifespan of the tool and result in a cleaner hole. The next process is cutting the workpiece to fit the 21mm length of the workpiece. The cutting process is executed by using a grinder. Since the grinder cannot cut through the workpiece entirely, it is only applicable to use the hacksaw as the finishing touch. After cutting the workpiece, another milling process is being executed. Then the process of drilling is again being executed on the side of the workpiece to get the two holes, which is 45 degrees from the center. The final process for part 1 is tapping.
First, we cut the provided metal sheet into a piece measuring 45 mm by 15 mm. After that, we remove any rough edges by grinding, and during this process we need to use glove to ensure safety. Next, we tapped the 3 holes according to the drawing. After that, we use a radius gauge to mark the half circle profile between the first and third tap holes before machining. Once the outline was marked, the workpiece was shaped into a half circle using the pedestal grinding machine. After completing the profiles, we drilled the hole using a 4.5 mm drill bit. Before the drilling, the drill position was checked to ensure the hole was aligned correctly and met the required dimension. The next step was face milling. We used the milling machine to machine the surface until it became 4 mm according to the drawing. Actually, while doing this step, there is a major problem, which is we can't mill the top of the metals directly. So, to solve this problem, we mill half of it first and then half of it. The face milling, the workpiece was finished using the pedestal grinding machine to further smooth the surface. Then, a larger drill was used to produce the countersink on the required hole, which is the middle hole. This allowed the screw head to sit flush with the surface. Lastly, the hole was threaded using a M5 x 0.5 tape. There's a problem in here, that is, the tape was turned too fast, causing excessive friction, and the result is the poor thread quality happened. For the solution, we need to thread it again, and it's happened to be good. Before we combine the part 1 and part 2, we spray the whole of the part 1 and part 2 so that we can avoid rusting in the future.
improvement that can be made, there are several improvements that can be implemented. First, a preventive maintenance schedule should be carried out regularly to inspect the pump, clean the components, and replace worn out part before failure occurs. Second, installing pressure and flow sensors can help monitor the pump performance in real time and detect any abnormalities at an early stage. Third, improving the part alignment and using high-quality sealing materials can reduce leakage and energy losses. Lastly, proper training for operator is important to ensure that the pump is operated correctly and safely, reducing the risk of equipment damage. In conclusion, proper pump installation is essential for achieving reliable and efficient operation. By implementing regular maintenance and continuous improvement, the overall performance, safety, and lifespan of the pumping system can be significantly enhanced. Thank you. That's all from me.
The first problem occurs is during the milling process. The milling process is the first milling process conducted on our project. It is where we remove the top part of the surface of the workpiece, where we accidentally remove more than what we needed and causing the workpiece to be shorter in length to what we needed for our length of the workpiece. Thankfully, our materials is more than 21mm in length so that we can have additional material to create a process of turning so that we can get the 21mm length of our workpiece. The second problem occurs is the boring process after we realize our first problem. The problem of the boring process is where we create a massive material removal at 45 degrees on the inside of our materials, which is caused by tool deflection and incorrect feed and speed. We fixed the problem by using a better tool for our boring process, and thankfully we were able to get the dimensionally accurate and precise of the inside hole for the workpiece. Another problem that we faces is the cutting of the material. The cutting of the material proved to be quite difficult for us to complete, since the grinder we used to cut the material didn't go through the material. Because of this, we wasted a lot of our time just to get through of cutting the material using a hacksaw. Another problem that we faces is to make a drill hole on the side of our workpiece. While drilling on the side of the workpiece, the drill almost didn't go through the workpiece and almost snapped to break. And because the angle is quite difficult to drill through the materials, the workpiece had a massive snap feedback to the working station, and because of that, there's a defect on the hole that is made on the side of the workpiece by the drill.